Welcome back. I hope you enjoyed your break. This is going to be a video for the lesson from the first day back in remote learning, and that is going to be on reviewing simplifying and operations with radicals. Everyone doesn't need to watch this because we're going to be going over this stuff in our Zoom, but if you missed the Zoom meeting and you wanted to watch what you missed, that's why I have this video. So, radicals. All right, we're still in our quadratics unit. All right, we're still going to be doing stuff with quadratics. We wanted to kind of start the first day with kind of like an easy day, something, not something totally new. So for the last third of our quadratics unit, because we've already taken our 2 quizzes, so we have 1 left. We're going to be doing some more stuff with radicals. All right, so we're going to be going over this today. Remember how to simplify a radical, all right? We have the perfect squares up here, all right? All the pink numbers are the perfect squares, right? The perfect squares are the number you can take a square root of and get a whole number answer. So when we are trying to simplify, all right here we've got radical 289, okay? The first thing you want to look for is that number a perfect square, okay? When we had our quiz on this a couple weeks ago, there was a question where it was like square root of 361, I think, and some of you were very confused by that. 361 is a perfect square, just like 289 is a perfect square, right? The square root of 289 is 17, so you don't even need to simplify this. It's just 17. I mean, that is simplifying it, but you don't need to actually break it up, okay? 96, okay? 96 is not a perfect square. So remember, now you are going to break up 96, and you need to try and think about what perfect square might go into 96. Now, if I'm looking at these perfect squares, I'm not exactly sure. 16 maybe? So what am I going to do? I'm going to open up Desmos, right? And I'm going to do the same thing that you guys can do. Divide 96 by perfect square. So I'm going to try 16, 6. There we go. So I got it. I was right. So we've got square root of 16 times square root of 6. Now remember, the square root of 16 is 4. That's why we wanted to break it up with a perfect square in the first place. So the square root of 16 is 4. And then we have radical 6, so our answer is 4 radical 6. And that's kind of what you're doing for these problems. Now, if there's a negative out in front, remember that doesn't mean anything, okay? That just means the negative is still out in front when we have our answer. So all we're trying to do is we're trying to simplify the square root of 144. We see here the square root of 144 is 12, so this is just negative 12, right? Now, negative on the inside, that does mean something, okay? You cannot take the square root of a negative number and get a real answer, all right? When you take the square root of a negative number, you actually get an imaginary answer, right? Remember, anytime you've got a negative on the inside, we're going to break it up into the square root of negative 1 times the square root of whatever number you had, and I don't know where we want to write this, but if you remember, the square root of negative 1 equals I. So anytime you've got that negative number inside your radical, all right, that's going to give you an I. So we already did from example C, the square root of 144 is 12, and then the square root of negative 1 is I, so this answer is just going to be 12I. So that's something that you got to keep out for. We're going over imaginary numbers again because I feel like we didn't exactly get it the first time. Let's see here. We got 3 radical square root of negative 32. So the 3, that's just going to be staying out in front, okay? We're going to break up the square root into the square root of negative 1 and the square root of 32, okay? Now we want to break up the square root of 32. Okay, so what's going to multiply into 32? Hope this one's a little bit easier than the last one, but it's also 16. It's 16 times 2. All right, so we've got 3i, because remember, the square root of negative 1 becomes I. So we've got 3i times square root of 16 times square root of 2. So the square root of 16, that's going to be 4. So we have 3i times 4 radical 2. And here, because you're multiplying, all right, you can just multiply these together. Now, you can't add things if they're not like terms, but we can multiply things. So 3i times 4, that's going to be 12i radical 2. And finally, that is our answer for this problem. So hopefully some of this stuff's coming back to you, all right? Let's go over these last couple. I don't think we went over this before. If you have a radical on the bottom, all right, you don't actually want there to be a radical on the bottom. So you have to do this thing called rationalizing your denominator. I honestly can't remember if we've talked about this year. This has been a crazy year. But if you do have a radical on the bottom, what you do is you multiply by the square root of whatever that number is on top and bottom. So we're not changing our number, right? Because multiplying by something over itself is equivalent to multiplying by 1. But what happens here is square root of 2 times square root of 2 is just 2, right? Because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. So you're always going to get that case where the square root of something times the square root of itself is just that number. On top, we've got 4 radical 2, and then 4 divided by 2 is 2, so we've got 2 radical 2 as our final answer. So that's called rationalizing the denominator. That might come into play later this unit, we'll see. G and H, not that difficult. G, you've got 2 numbers, one on top and one on bottom, that are both perfect squares, so we can just take the square root of those numbers. We definitely have done this before. Square root of 16 is 4, square root of 49 is 7, so this is just 4/7. For H, we only have one number, right? That is a perfect square. We've got square root of 81, which is 9. But then on bottom, we've got square root of 5. So again, we're going to have to rationalize the denominator here, all right? And so we've got to multiply by the square root of 5 over the square root of 5. Once again, the square root of 5 over this times the square root of 5, that's just going to be 5. And then we've got 9 radical 5 on top, and this can't be simplified any further, so this is just your answer. So that's a lot of stuff on simplifying radicals. It hasn't been that long since we've done this. Like I said, only a few weeks, but hopefully this is kind of easing you back into it, rejogging your memory a little bit. The last thing that we're going to talk about is some operations with radicals. Now, you would have done this in Algebra 1, but we haven't done this yet. Simplifying radicals, though, is a lot like combining like terms, okay? So we got 2x squared plus 7x squared, right? Hopefully we all know that's 9x squared because 2 plus 7 is 9. They both have x squared, so that means they're like terms, and the exponents always stay the same when you're adding or subtracting. Here you got 2x cubed minus 7x cubed, so that's going to give us minus 5x cubed. Here, though, 2x squared plus 7x, not like terms, right? So we cannot actually add those together. So simplifying it, it's already simplified, all right? So you can only combine like terms. Similarly, you can only combine like radicals, okay? So you can only add or subtract if the number inside the radical is the same, okay? So what I mean by that, so if we have radical 5 plus radical 5, all right, that's kind of like the same thing as saying x plus x, okay? If you think about x being radical 5, okay? So we all know x plus x is 2x, so radical 5 plus radical 5 is just 2 radical 5, okay? Because you have 2 of them. So you treat the radicals just like you treat variables, and you do the math the same way. So here we've got radical 8 plus 2 radical 8. That's going to be in total, we end up having 3 radical 8s, okay? If we come over here, we've got 7 plus 2 radical 9 minus 12. Well, this is a radical and these don't, so we can't add them together. However, we can do 7 minus 12. So that'd be 2 radical 9 minus 5. It's negative 12 plus 7. Now, one thing you might have noticed is the radical square root of 9 is 3. So, we can kind of do 2 times 3 is 6. 6 minus 5 is 1. So here we can actually go all the way down and get a whole number answer. 6 minus 5 is 1. And i's work the same way. Okay, i's just like a letter. So negative 3i minus 4i, that would be negative 7i. 5i minus 11 does not simplify. Okay, the answer is just 5i minus 11. You can't add or subtract things if one has an I and one's a number. Okay, they're not like terms. This is what we call a complex number. All right, it has a real part and an imaginary part. Those two parts can never combine unless you're multiplying, then they can. Here, 12 plus I minus 2 plus I. So think about combining like terms. We have 12 minus 2. That's 10. And then we have plus I, so that'd be plus 2i, and that would be our answer. So I know we kind of went over a lot in this video. Most of it wasn't new. Some of it was. What you guys are going to do to finish is this back page, okay? If you have any questions on it, you can always Canvas message me and let me know, or you can always ask them in the next Zoom session. But hopefully this video was helpful. And have a great day.